What more fitting Valentine story than the saga of SohCahToa? Our two star-crossed lovers have been reunited. They're back together in their home, and it's time for the epilogue. That's right. Back together again. They need to continue redecorating their new open concept home. And so first thing they set out to do is to figure out the area of their new home. Now, they know that the angles, of course, let's relabel. The angles and sides have their own names. And if they want the area of this triangle that they now live in together, they know from a past experience that 1/2 of the base, here the base is C, the base of their triangle, times the height of their triangle, which pretty much got knocked down in a little wall destruction that you know about. So it's not even there, but the measured height of that triangle would be the area of their home. So 1/2 the base length times the height gives the area of the triangle. But they don't know the height, except they know SohCahToa. So SohCahToa is like, oh, no problem, hun. Let's take care of it. If angle A is here, then the sine of angle A is the opposite, the height number, divided by the hypotenuse B. Solving for H by itself would be B times the sine of angle A. So let's just take that little expression and bring it right down here. And we have an area formula that does not require us knowing the height. C times B sine of A, replacing the height with B sine of A. Okay, so in general, if you have a triangle and you know one angle, that's our angle A, and you know the two sides that form it, that was our B and C. So if you're given, again, that side angle side pattern, then you can use the area formula 1/2 the product of the two sides. I'm going to flip-flop the B and the C, just alphabetically, and the sine of A. So again, it's 1/2 the product of the two sides times the sine of the angle that they form. Okay, quick example. Just so we don't get stuck in the same picture, this is going to be 10, this is going to be 12, and this angle between them we'll say is a 40-degree angle. I'd like to know the area. Ooh, you know what? I'm going to get away from calling area A because that's sine A, angle A, area A. This is a bad idea. Let's just write out area. Okay, so the area of this triangle is 1/2 the product of the sides, so 10 times 12, 1/2 of 10 times 12, times the sine of the angle they form, sine of 40. Okay, that goes into the calculator, lickety-split. Let's see, clear out our last one. So we've got 1/2 times 10, or just times 12, times the sine of 40 degrees. 38.567. That's the area of our triangle. Let's practice units a little bit. So if these were centimeters, we'd make sure our area has a centimeter squared unit on it. And that's our answer. Okay, now there's another formula that you can use to find the area of a triangle. This one is used when you have side angle side given, like I said. But there's another formula that's used when you know all three sides. So all three sides of a triangle, we'll just call them what we have been. Let's say A, B, and C. If you're given all of those, side, side, and side, then you can use the formula called Heron's formula. All right, now Heron's formula looks like this. Its area is equal to, and then there's a big, huge square root involved, so make it big, S multiplied by the quantity S minus A times the quantity S minus B, and one more quantity, S minus C. That's an S. I don't know why it came out like that. All right, so you might be wondering what the S stands for. I hope you are, because that's a good question. That's where S is 1/2 of A plus B plus C. So A plus B plus C all divided by 2 is what we call S. The reason we choose the letter S is because it represents the semi-perimeter. So S is the semi-perimeter. Think about what perimeter means. It means you're going to add all the sides up, and semi is the idea of cutting that total in half. So you see the perimeter is A plus B plus C, but then we cut it in half to create the semi-perimeter. And that number is used in 4 different spots in this formula. Okay, let me run you through an example of this. So pretty much, if you have any triangle and you know the 3 sides, let's just say this is 10. This one's going to be, I don't know, 12, and we'll make this one 13. Okay, so what I do first is I set out to figure out what the semi-perimeter is. So the semi-perimeter will be, let me add these sides, 10, 12, and 13. We'll get that total and divide it all in half, which I usually can do that with a calculator, without a calculator, but yeah. Okay, who am I kidding? I'll mess it up somewhere. So adding them up is 35 divided by 2, 17.5. All right, so the semi-perimeter, half the perimeter is 17.5. Now we go to the formula for area. Big square root, starting with the 17.5, we put in for S, then S minus A, S minus B, and S minus C. So essentially we're subtracting one at a time each of the 3 sides from the semi-perimeter. So 17.5, let's say 10 is the A, doesn't really matter. 17.5 minus the 12, and 17.5 minus the 13. And I didn't make my radical long enough, so let me extend that, make sure that extends across the whole product. Okay, so 17.5, let's see, let's do the subtraction. This would be 7.5. This would be 17.5 minus 12 is 5.5, check me. And 17.5 minus 13 is 4.5. Okay, now I'm going to get my calculator. Let me just actually put in a big square root, and it'll keep expanding. So I'm going to enter 17.5 times 7.5 times 5.5 times 4.5. And that just expands the square root all the way across it. Enter, and that's my answer. The area is 56.995, and I didn't give units. Probably should have done that. Let's call these miles. This is going to be a huge triangle. Miles. So we got square miles here. Okay. Now that is Heron's formula. It's pretty simple to work with. It's crazy insane to derive. Heron's formula, I'll tell you what, if you guys ever run across formulas or theorems that are named after someone, that's because these are the people where you're like, who thought of this? Who ever would have thought of this? Well, it was Heron, and he proved it. And I'll send you a text or some information about extra credit where you can learn a little bit more about Heron's formula, where it comes from, and then appreciate how nice it is to use. All right, that's it.